Hi, welcome to section 1.2, part 2. All right, we left off talking about how to deal with place value. So here's an example of types of problems which help develop problem place value skills in grades kindergarten through 3rd grade. So for my first example, use counting blocks, remember use those physical representations, to first represent 39, 89, 453. So you have kids build those. Okay, so let's just build the 39 for right now. And we're going to use the chip model since we don't have manipulatives in front of us. There's my 39. Okay, and what they want you to do is, let's deal with the 39, and they want to know, hey, if I add 1 to it, so basically I'm saying, hey, 39 plus 1, why isn't the answer 3010 instead of 40? And so you would just have the students add 1 to it, and then they can see, oh, I have to rebundle, and my answer is 40. Okay. Another example would be when we're adding different place values. So I'm going to actually change this problem to 121. So what number is 121 more than 532? Explain how you could use bundles or counting blocks to explain this to your students. We're going to use the chip model again. So I'm going to draw 532. One, 2, 3, 4, and 5. 1, 2, and 3, and 1, 2. And what I want to do to that, so I'm going to have 532, and I want to add to it. So what I'm going to do is I'm going to put a dotted line right here. I'm going to add to it 121. And so then what the students can see is, oh, I just take 2 plus 1 and I got 3. 30 plus 20 is 50. And then 500 plus 100 is 600. So notice we didn't do any carrying or bundling or anything like that. We're just adding place value. And so then my answer is 653. You're getting them to see that you add each place value separately. Okay? All right. So objective 3, it says, understand how to use expanded form. You can also use the chip model to explain this value, or the explain place value. So we just got done doing the chip model. Now let's do the same thing, but we're going to do expanded form. So let's do 532 plus 21. So remember, expanded form is when you rewrite the problem as each of its place values 500 plus 30 plus 2. So when we add doing that, 532 plus 121 will look like this. 500 plus 30 plus 2, and we're going to add to it 100 plus 20 plus 1. And then we add, and we get 50 here, and we get 600 here. So we have an answer of 653. Okay, so that's how you break apart things into expanded form. All right, so why is place value important? So we said that place value is important in adding and subtracting because when you add each place value separately. We can carry later. But it's also important for multiplication because it can help us learn how to multiply easily. And so we can multiply any number by 10 by appending a 0. So let me write that down and explain what that means. We can multiply any number by 10 by appending a 0. All right, so what does that tell us? That means that if I take 4 times 10, that gives me 40. But if I take 4 times 100, that gives me 400. If I took 4 times 1,000, that gives me 4,000s. I'm writing this out a little bit more, which will then give me 4,000. Okay, so basically every time you multiply by the zeros, the kids can hopefully see that the pattern comes that we're just adding those zeros at the end to represent each place value. All right, it also helps us when we're trying to explain to kids about which is larger. So if I have the number 75 and the number 57, which one is larger? How would the students tell? Because remember, students, when they see 75, they see a 7 and a 5, or they see a 5 and a 7. They don't see a difference. So what you could do is you can use expanded form and say, well, this is equal to 70 plus 5, and this is equal to 50 plus 7. And you're hoping that, hey, 70 is more than 50, so therefore 75 is greater than 57. And so that's one way. But what you want to do in the classroom is you might want to first have them create a number with the base 10 blocks so that they can see them. Have them use the chip model so that they can draw it. And then once they use the chip model, then have them write out the expanded form so that they can see what's going on. So that's how you're going to slowly increase their understanding of which number is greater. Okay. All right. Once they can understand place value and they can understand how to order numbers, now it's time to get them to understand regrouping. Okay. So regrouping or rebundling, your book is going to use rebundling for their word. But we're going to use regrouping usually when we talk during class. So there's different types of rebundling or regrouping. The first one is to compose a 10. This is for addition. So that's when we have more than 10 things in each place value, and then we're going to move them to the left. Now, a decomposing of a 10 deals with subtraction. And that deals more with your borrowing because you can't subtract each place value. So let's look at the expanded form and maybe the chip model really quick with composing of a 10. Let's look at 74. We're going to look at this one from down here. Let's look at 74 plus 6. So if we do the chip model quick, 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4. And I want to add to it 6. 1, 2, 3, 4, 5, 6. So then I can see that 74, that the 6 plus 4 is going to bring a 10 over. So 74 plus 6 is equal to 80, because what's going to end up being left over is nothing in the one spot because we carried them over, but there's going to be 8 tenths. Okay, let's see what expanded form looks like. And I'll put the expanded form up above here. So let's do 74 plus 6. Well, that's 70 plus 4. And then we have plus 6. This is equal to 10. And this is equal to 70. We could break that 10 up into 10 plus 0, because you got to break it apart into the 10s and the 1s. Add those together and you get 80 plus 0, which is equal to 80. Right? Now subtraction, that's when we're borrowing. So suppose we have 43 minus 15. Let's do the expanded form first. So I have 40 plus 3. I'm going to subtract 15, which is 10. And then we're going to subtract 5. So you're subtracting 10 and a 5. So be careful with subtraction. I can't take 3 minus 5. Can't happen. And so I'm going to borrow from it. And that's going to give me 30. And this is going to give me 10 plus 3, which is 13. And 13 subtract 5 then would be 7. And then this would be 20. So my answer is 27. I will show you the chip model later with subtraction. It's a little bit different than addition. Okay. All right, and we already went through this example. And I'm going to show you this example when we talk about subtraction. And we'll continue doing more with adding. So the final examples we'll cover in the next sections. Okay. Thank you.